Hello everyone. So we will be discussing about the multiplication rule of probability. So the multiplication rule is a way to find the probability of two events happening at the same time. And there are two multiplication rules. The first one is general multiplication rule, having the formula of probability of event A intersection B is equals to probability of A times probability of B over A. Next one is the specific multiplication rule, having the formula of probability of event A and B equals to probability of event A times probability of event B. In the probability of event B over event A means the probability of A happening given that B has occurred. So the specific multiplication rule, it is only valid if the two events are independent. In other words, it only works if one event does not change the probability of the other event. So examples of independent events. First is owning a cat and getting a weekly paycheck. Second is finding a parking space and having a coin for the matter. And the next one is buying a book and then buying a coffee. Using the specific multiplication rule formula is very straightforward. Just multiply the probability of the first event by the second one. For example, if the probability of event A is 2 over 9 and the probability of event B is 3 over 9, then the probability of both events happening at the same time is 2 over 9 times 3 over 9 is equals to 6 over 81. Then it will result to 2 over 27. So the next one is multiplication rule of probability using the general rule. This rule can be used for any event which are independent and dependent events. You still have to multiply two numbers, but first you have to use a little logic to figure out the second probability. So first, let's define independent and dependent events. So independent event. Two events are independent if the result of the second event is not affected by the result of the first event. If A and B are dependent events, the probability of both events occurring is the product of the probabilities of individual events. Having the formula of probability of event A and B equals the probability of event A times probability of event B. For example, a box contains 4 red marbles, 3 green marbles, and 2 blue marbles. One marble is removed from the box, then replaced. Another marble is drawn from the box. What is the probability that the first marble is blue and the second marble is green? So we have the probability of blue and green is equals to the probability of blue times the probability of green. So we have the probability of 2 over 9, which is the blue, times the probability of 3 over 9, which is the green. So it will result to 6 over 81, then reduce, it will be 2 over 27. So next is the dependent events. Two events are dependent if the result of the first event affects the outcome of the second event so that the probability is changed. With the formula, probability of event A and B equals to the probability of event A times the probability of event B. For example, a jar contains 5 red marbles and 10 blue marbles. 2 marbles are drawn from the bag without replacement. What is the probability that both marbles are blue? So let A be the event that marble 1 is blue and B be the event that marble 2 is blue. Determine the probability of A. So since there are 10 blue marbles and the total is 15 marbles, so the probability of drawing a blue marble is 10 over 15. Next is the probability of B. Since we already get the probability of A, so there are only 9 blue marbles left and 14 marbles for the total. So the probability of B is equals to 9 over 14. So proceed to multiply of probability of A and probability of B. That will be 10 over 15 times 9 over 14. And that will result to 90 over 210. Then reduce, that will be 3 over 7. In this example, the first marble is not replaced. The sample space for the second event changes. The probability of both events occurring is the product of probabilities of individual events. Therefore, this is independent event. So let's proceed to the next example.
Independent events. When we say independent, it means it doesn't depend on anything else. It do not influence one another or have any effect on how probable another event is. For example, here we have two dice. Our first die is our event A, while the second die is our event B. Given these events, the multiplication rule states the probability that each event is observed by multiplying the possibilities of every event. So, if A and B are independent events, then probability of A and B is equals probability of A times probability of B, which it becomes our formula. In some versions of formula, instead of using AND, we can use the intersection symbol. Suppose we are rolling a 2 6-sided dice. The probability of rolling one die is 1 over 6. The probability of rolling the second die is also 1 over 6. The probability of rolling two dice is 1 over 6 times 1 over 6 is equals 1 over 36. If we're going to list all the sample space, here it goes. In total of 36.
Multiplication rules of probability. Dependent event. The probability of A and B occurring, so we'll use the intersect symbol for A and B is equal to the probability of A occurring at the same time as the probability of B occurring, provided by that A has already occurred. So this is the guide or formula. Probability A and B equals probability A times probability B and A. So if there are 12 marbles in all 3 green, 4 blue, and 5 red, our equation looks like this. The probability of removing green and blue is equal to the probability of removing green multiplied by the probability of removing blue after green have been removed. So this is my formula. Probability green and blue equals green times probability blue and green. So for the final page, if we had put the marbles in the back, it would still have a probability of putting out the green to be 1 over 4. But the probability of pulling out the blue will now be 4 over 12 is 4/12, so which can be reduced down to 1 over 3. Therefore, the probability of having pulled out a green and blue after replacing the green 1 would be equal to 1 over 4 times 1 over 3, which is equal to 1 over 12. So that's all. Thank you.
Dependent event using cards as an example. So there are 52 total cards, and in this example we will only be using ace and king, which ace has 4 cards and king has also 4 cards. And please do remember that event A will be representing ace and event B will be representing king. Also take note that the formula of dependent event is probability A and B equals probability A times probability BA. So let's proceed. Probability ace and king equals to probability ace times probability king ace equals 4 aces over 52 cards times 4 kings and 51 cards remaining, since we are holding into an ace. Then we will multiply this probability together. 4 times 4, 52 times 51, which could equals to 16 out of 2,652 equals 1 in a chance of 167. So 1 over 167 is our final answer.
Independent event. So the formula of this is the probability of A and B and C equals to the probability of A multiplied by the probability of B multiplied by the probability of C. So independent event, 3 coins. So the probability of the 3 events, which is the coins A and B and C, is equal to the probability of A multiplied by the probability of B multiplied by the probability of C. So if the probability of the first coin multiplied by the probability of the second coin multiplied by the probability of third coin, which is 1/2. So 1/2 times 1/2 times 1/2. So 1 times 1 equals 1 times 1 equals 1. 2 times 2 equals 4. 4 times 2 equals 8. So the answer is 1/8.